Okay, it's Mr. Herman with another video. This time we're going to be talking about the cube. We did this one in class today. Of course, it depends what day you're watching this, so it won't be necessarily today, but we did it on May 11th, I believe. So we're looking at the surface area of a cube. We know the surface area of the cube given to us, and then it says a hole that's a centimeter in diameter is drilled into one of the faces and goes all the way through to the other side. You want to find the volume and surface area of the cube after the hole is drilled. Why don't we start by kind of drawing out a cube? It doesn't need to be exact. We're just trying to get the best, some kind of a picture to help us a little bit. And the picture comes in handy later on, too, when recalculating the amount afterward. So let's take and draw a cube out. Kind of like this. And then we're going to draw a hole in the middle. I'm going to say that that hole kind of has, like, goes through the other side. So that hole, hopefully we figured out already, is a cylinder. It's a cylinder. If you drill a hole, the cylinder, the drill bit, actually it's a cylinder with cuts in it, of course, but it drills through. And so we've got a 1 centimeter diameter, and we've got no edge length at all. All we know is that the surface area is 47.04. So based on that, we can figure a lot out. First of all, we know the surface area formula for a cube is 6 times a side length squared. Sorry about my S's looking like 5s. I do my best to keep pointing out. That's an S right there. That's an S for side length. That side length is like one of these. It's a side. They're all equal on a cube, so all the side lengths are the same, and that's S. So we can set the 47.04 equal to 6S squared, and then divide both sides by 6, and that gives us 7.84. And then take the square root of both sides. Again, there's that half power button, caret 0.5 you could do too. And we get a side length of, that's an S, 2.8 centimeters. So now I've got like 2.8 centimeters here. I got it right here. Every one of these measures 2.8 centimeters. I'm not going to put that on all the sides, just so we can kind of see. 3 is enough. You've got a height here. You've got a base, and you've got a depth. You know, you've got enough there to figure this out. So from there, why don't we figure out the volume first? The volume's actually easier. So the volume is going to really be the cube's volume, minus the cylinder. And that's spelled right. It's close enough, though. Minus the cylinder, okay? So from there, we're going to take the cube volume. We know that is to be just one side cubed. So that's S cubed minus the cylinder, pi r squared times the height. So let's plug some numbers in here. We've got a side length of 2.8 cubed minus 3.14 times the radius of 0.5. We've got to cut that diameter in half. Squared times the height. Now the height of this is the same as the depth here. And that's also 2.8, which makes this 2.8 also. So the height of the distance between the bases, that is the height of the cylinder, is 2.8. So if we put all that in, running out of space, so I'm going to go sideways here. We should get a volume of 19.754 centimeters cubed. So there's our volume. Again, we didn't even start by knowing the volume, but we still could figure it out based on the edge length. Just need that edge length. Now the surface area is a little bit harder, but not that much more. Here you're going to take the cube, which we have the original surface length for, thankfully, and we're going to take that and subtract the 2 circles. Remember, these 2 circles here, these are just air. There's nothing really there. That's just a hole, so you don't count that. So you got to take it out of the formula that you normally use. In the normal formula for the cylinder, of course, is 2 pi r squared plus pi dh. And we're going to only use part of that. We're going to use this part. Because on the inside, if you had to go inside and paint the inside of this, you'd have to paint there's surface there. So we have to add this, but subtract the circles on the end. So minus 2 pi r squared for that part, and then plus the pi dh. That's the lateral area of the inside of the cylinder. So the cube is going to be, well, we already have the surface area for that, so that's kind of easy. 47.04. We're going to subtract 2 times 3.14 times the radius, still 0.5 squared. And now we're going to add that the lateral surface. So 3.14 times the diameter of 1 times the height, which was the same as before, 2.8. And again, you can pause this any time if I'm going too fast. You should get a finished surface area now of 54.262 approximately centimeters squared. So those are our two answers to this one. Here's your surface area, and the volume is up there, 19.754. Again, let me know in class if you have any questions about this, or you can send me a message through YouTube. Thanks so much.